2.7 notes are two variable inequalities. It's very important that when we are doing our inequalities that we are comfortable with actually graphing equations first. So we're going to start with a little bit of a review with just graphing equations. So we're going to start on just practicing graphing linear equations and absolute value. We're only going to do two linear equations because I think you guys are a little bit more confident with that. The -7 is going to be your y-intercept. So here's your y-axis, this is your x-axis. So the y-axis, this is going to hit at -7 on the y. Now, I put scales on here. They are going up by ones, but I didn't label every one. So 1 labeled 2, 3 labeled 4, 5 labeled 6. So you can count them that way. You could label to every single one. I don't like to do that because then my numbers look too squished and it gets a little bit confusing. So -7 is right here. My slope is 2/3. My rise is 2, rise over run. So rise 2, run 3. Up 2, right 3. Now I have a scale of 1, so I can count up 2, right 3. And I'm going to keep going until I run out of graph. Then I'm going to move in the opposite direction also until I run out of graph. I'm going to make sure I use a straight edge when I go to connect these, because if my straight edge doesn't go through all the points, then something is wrong with one of my points. It does go through them all, so I'm pretty confident that that's how I'm going to graph that equation. I'm going to move to the next one. This next one has a y-intercept, here's the y-axis, at -2. Now notice this one, I have a scale of 1 on my x-axis, 1, 2, 3, 4, but my y-axis is 2, 4, 6, 8, 10, 12. So I did a scale of 2. So my -2 is right here. And now my slope is 3. So when I go up 3, this is up 2, here's up 3, right 1. Okay? So you have to be careful. That's 3 over 1, so rise 3, right 1. Now, depending on what your slope is, that's up 1, 2, 3, right 1. And then from there, you can kind of usually see a pattern. You're going up 1.5, right 1 on the actual graph. And you're going to go in the opposite direction. You're going to make sure to get as many points on there as you can. And then if you connect it with a straight edge, if you weren't sure how to do that, you could always resort back to making a table. If you're unsure, plug in 0, plug in 1, plug in 2, plug in 3. Once you plug in those values, 3 times 0 with 0, 0 minus 2 is -2. 3 times 1 is 3. 3 minus 2 is 1. 3 times 2 is 6. 6 minus 2 is 4. And then you have points to actually plot. So 0, 2, 1, 1. 2 is at 4. 3 is at 7. And make sure that your coordinate points are plotted accurately. The ones I think you're going to need a little bit more practice with before we do our inequalities are absolute values. So when you add 3 on the inside, this shifts left 3. So if our origin is our vertex of the vertex of our parent function, if we go left 3, 1, 2, 3, our new vertex is going to be right there. This one is going to be the same as your parent function though. The slope is 1, so you're going up 1, right 1, up 1, right 1. Now be careful, because that's the right side of your v. Don't come over here and think it's a linear equation where you just have a line. That's the right side of your v. Your left side of your v has a slope of -1. So down 1, right 1, or up 1, left 1. And we only go up 1, left 1 because we're creating that v. You could have also said I'm going to go up 1, out 1, up 1, out 1. You could do it that way too. That's the way I usually do it. Up 1, out 1. Because that's how the parent function moves. So that's that one. Now this one goes to the right 5, and it goes down 7. That's where your new vertex is. So the right 5, down 7. So right here, there's your new vertex. Now this one also doesn't have a multiplier out front, so it's going up 1, out 1, up 1, out 1, up 1, out 1, just going to keep doing that until you've run out of graph. All right. Then, this one goes to the right 3 and down 2. So that's going to be where your vertex is. To the right 3, down 2. However, this one now has a multiplier. Rise 2, run 1. It is a V, so we're going to be going up and out. So up 2, out 1. And we're going to keep going with that until we have a nice V. There's our V. Connect the points. And there's our absolute value graph. Now this one goes right 8, up 1. And when we do right 8, up 1, there's the vertex of our graph. Now this one, though, has a negative multiplier. So this one's going to be the mountaintop. Okay? The 1/2 tells you that it goes down 1, out 2. Down 1, out 2. And that's your graph. Okay, so now that we did that little summary on graphing, we can go on to our 2.7 notes, which is to graph both linear and absolute value, inequalities. Okay, so when we're looking at equations, any solution to this equation is any point on the line. Now, it's more than just the points that we drew in, because technically there's a point in between. And if you go in between those, there's another point in between. And you can accurately find where 7's at, or where 7.5 would be located. Okay, so there are infinite number of points on this line, but any point on that line is a solution to the equation. When we move to an inequality, specifically a linear inequality is still going to be made up of a linear equation. However, an inequality in two variables whose graph, okay, so it's an inequality, has a graph, and whose graph is a region of the coordinate plane. So when we graph an inequality, your solution is actually a region of the coordinate plane. So it would be possibly this line, it might not be the line, and the area underneath, it's an entire region. Okay, so that's what a linear inequality is, or an absolute value inequality. Symbols that represent inequalities are these that we already know. So this is a less than, greater than, less than, or equal to, greater than, or equal to, and this is not equal to. When we go to graph, if we have a less than or greater than symbol, these are going to be a dashed boundary line. And the boundary line is not going to be included if it has to be less than or greater than. If it's or equal to, these would be a solid boundary line. And then the line is included. Okay? So it's going to look like an equation, but it contains one of these symbols instead of an equal sign. So it's going to look like an equation, but it contains these symbols instead of an equal sign. So we're going to talk about how linear inequalities look on a coordinate plane. So the first one is to graph y is less than or equal to 1/3 x minus 4. Now what we're going to do is we're going to pretend that this says y equals 1/3 x minus 4, and we're going to graph it just like how we know how to graph that equation. Subtract 4, or go to the y-axis, go to -4. That's going to be your y-intercept. Your slope says to go up 1, right 3. Down 1, left 3. So there's our line. Now don't connect them yet, because that's when you need to look back and say, okay, I'm not graphing an equation now. What I'm graphing is an inequality. Now does this inequality, is it going to be a solid boundary line or a dashed boundary line? This one is one of these, or equal to, so it is going to be solid. So we have a solid boundary line. Okay. The solid boundary is part of the solution. So any point on here, if you were to plug it in, that inequality would be true, and it is part of the solution. Okay. Now we have to shade. So when we have y compared to the expression, y, the y-axis, goes up or down. So what you're going to do is you're going to read it. Y is less. So put your pen or pencil on the y-axis. Where is y less than -4? Down here at -5 and -6. So that's the side that we have to shade on. Now if it had x and y on that side, we would have to either get a alone, or what we could do is we could plug in a known point and see if it works or not. So for example, let's say I wanted to plug in 0, 0 and see if 0, 0 works. Is 0 less than or equal to 1/3 times 0 minus 4? Well, when I simplify the right side, that turns into 0 minus 4. Is 0 less than or equal to -4? It's not. So 0, 0 is not part of the solution, which we can see it's not shaded. The shading is part of the solution. So if you plug in a point and it's not part of the solution, then you're going to shade in the opposite direction. 0, 0 is the easiest point to plug in. If it was a dashed boundary line, it's not part of the solution. So is 3, -3 part of the solution? Yes, because it is on a solid line. Is 5, -5 part of the solution? Yes, because it's part of the shaded region. 0, 0 is not part of the solution because it's not shaded or it's not a solid line. This next one, our y-intercept is at +1. So you're going to put that point on there. The slope is -2, so down 2, right 1. Once you have all the points on there, all the points that you can fit, we have to see, do we connect them with a solid line or a dashed line? Since this is just greater than, we are going to use a dashed line. So I'm not going to connect it with a solid line. I am instead going to make it a dashed line. Now y is being compared. So put your pencil or pen on the y-axis. Y is greater than 1. Here my pencil's at 1. Where? Up here at like 2, 3, and 4, y is greater than 1. It's not greater down here, so I'm going to point my arrow that way. That tells me that I need to shade on that side of this boundary line. So when we graph linear inequalities, our steps that we follow are 1, graph the boundary line. And at that point, you're just doing points only. Okay? And then you will have to see if you need to connect with a solid or a dashed line. And then, once you do that, you need to shade the graph, because our graph is a boundary. It is no longer just the line. It is a boundary. It's an area. Okay? Okay, so if we flip this over, we have a couple more. Graph the following. Here's another linear. Our y-intercept is at -3. Our slope is 2. 2 right 1. We put all the points on there. Then we look at our sign and we say, do we need to connect these with a solid line or a dashed line? This one needs a dashed line. Once we have our dashed line on there, y is less than, so put your pencil on the y-axis. My y is at -3. Where is y less than at -3? Down here at -4 and -5. So that's the side of the line I'm going to shade. Now, if I said, is 0, 0 part of the solution? No, it's not. 0, 0 is not part of the solution. Is 2, 1 part of the solution? No, it's not, because it is part of the dashed line. Is 6, -2 part of the solution? Yes, because it is in the shaded region. X is greater than or equal to -4. This is a vertical line. Remember, an x equals or a y equals, those are the only equations that do not need an x and a y. They're special. They're either a vertical line or a horizontal line. The x equals goes through the x-axis at -4. So it would make sense for that to be a vertical line, because if it was a horizontal line, it would just be the x-axis. So it's a vertical line. Is it a solid line or a dashed line? A solid line. So we're going to draw that solid line through the x-axis at -4. Now, since this is an x is greater than -4. Put your pen or pencil on the x-axis at -4. What x values are greater than or equal to -4? The greater than or equal to are things like -3, -2, -1, 0, 1, 2, 3, all of these. So we go to the right if you're looking at x is less than or greater than. Okay? Most of the time it's y that we're comparing, and in that case, we would go up or down. So now we can see which side of the graph we're going to shade on. So we're going to shade that side of that boundary line. Next one, this one is in standard form. So we're going to have to do a little bit of work here to get y alone. The first thing that you're going to do, I'm going to rewrite it up here, is add 5x to both sides. 5x and 8 are not like terms. Over here you have no x term left. -2y is greater than 5x plus 8. Now what you'll have to do is divide everything by -2 to get rid of that coefficient in front of y. However, when you divide an inequality by a negative number, that's when we have to remember that the sign flips. So y is less than -5/2x minus 4. Now I know how to graph that. My y-intercept is at -4. Put that on there. I go down 5 and I'm out of room. So I'm going to instead go up 5, left 2. Make sure when you're reading it like a book that it shows up as a negative slope. Up 5, left 2. Now, do I connect it with a solid line or a dashed line? A dashed line, because it doesn't have that line underneath. So it's not or equal to. In the original or the end, those don't change. The only thing that changed about that sign is the direction it was going. Now, since the y is alone, we can look at it. And I'm going to show you in this case how we should test a point. Because if you manipulated this equation, there's a chance that you forgot to flip the sign. We could see, though, if we look at our y is at -4, where is y less than that? Down here at numbers like -5 and -6. Okay? I'm going to show you, though, how you can use your original so that way you don't have to trust your sign that you remembered to flip. You will have to trust that you moved things and divided by things correctly. But if you forgot to flip your sign, this way will keep you safe. So 0, 0. -5 times 0 minus 2 times 0 is greater than 8. We're going to see if this is true. That turns into 0 minus 0 is greater than 8. Is 0 greater than 8? No. So because of that, I'm not going to shade on the side with 0, 0. Instead, I'm going to shade on the side opposite that 0, 0 is. Which you can see, yes, I was going to shade the correct way when I lifted that arrow, but that's because I did this accurately and I remembered to flip the sign. If I forgot, I would make a mistake there. So you can always check a point to your original equation to make sure you shaded in the correct direction. And 0, 0 is always the easiest point to plug in. The next two are absolute values. Okay? This one, we're going to want y by itself. So I would add 3 to both sides. You get y is greater than or equal to x plus 2, and on the outside, we've now added 3 on that side. This goes to the left 2 and up 3. There's no numbers out front, so that means that the slopes on the v are the same as our parent function. So up 1, out 1, up 1, out 1, up 1, out 1, up 1, out 1. Then you have to pay attention. Is this going to connect with a dashed line or a solid line? It's or equal to, so we have a solid line here. Now y is greater. Okay, so when we look at this, go to your y-axis. Where is y greater than 5? Up here at 6. So on this side of that boundary line. So our boundary line is a V. So it's going to be the inner part of the V that is shaded. All right, last one here. This one. How does it move? There's no adding or subtracting on the inside, so it doesn't move left or right. It goes down 1. So there's your vertex. It is upside down because of that negative, and that slope tells you it goes down 2, out 1. Down 2, out 1. Down 2, out 1. Now let's look. We're going to connect that with a dashed line. And then we need to look at y is less. So go to your y-axis, -1. Where is y less than -1? Down here at -2, -3, -4. So that is where we're going to shade on this one. Is another one where it's inside the V. It could be, if it was greater than, you would shade all of this area. Okay, but it's not. So that is that for your assignment. You could also, if you weren't sure about the shifts, you could have done a table. So here you would have taken x plus 2 and set it equal to 0, just like how you know how to do. X is then equal to -2, and that tells you to put -2 in the center of your table. That means you would find -3, So then you would plug in these values to your equation. So negative 4 plus 2 is negative 2. The absolute value of negative 2 is positive 2. 2 plus 3 is 5. Negative 3 plus 2 is negative 1. The absolute value is 1.
Reminder staff, there's a staff meeting in the media center at 2:20.
1 plus 3 is 4. Then negative 2, that turns into 0. The absolute value of 0 is 0. 0 plus 3 is 3.
Sorry, my mistake. It is online, not in the media center.
Sorry about that. So then when you plug in these ones, this is what you get to. So either way, when you were to go to graph this, 0 is at 5, negative 1 is at 4, negative 2 is at 3, negative 3 is at 4, negative 4 is at 5, and you would get those couple points and then be able to extend it from there. And you could do the same thing here if you wanted to make a table as well, but that's totally up to you.